Now I'm going to show you how to solve an OR inequality. Well, first you could be wondering, how do I know if it's an OR? Well, hopefully you're not wondering that because it's pretty obvious. When it says an OR, it's an OR inequality. That's the nice thing about it. And so we look to this and say, well, what do I do first? Unlike an AND inequality, there's nothing we have to do to get started. The only step is to solve each inequality as if it were separate. So looking at this one, I first know I don't need to distribute anything. I don't need to combine like terms on the same side. I don't need to move variables. So all I need to do first is undo this addition. So I'm going to subtract 1 from both sides. Well, subtract 1, so I'm left with 3x is less than 3. Then I go ahead and divide both sides by 3. So this gives me x is less than 1. I'm going to write the OR. Looking at this one, I'm going to solve it too. So look at the steps. Well, the first thing I need to do is undo this minus 5. So undo minus 5, I'm going to add 5 to both sides. So this leaves me 2x greater than 12. From here, I'm going to go ahead and divide both sides by 2 to undo this multiplication. And so I'm left with x is greater than 6. So similar to an AND inequality, what I'm going to do is I'm going to graph both of these inequalities on the same number line to see what does their relationship look like. So for this one, I'm going to graph it in blue. So this is x is less than 1. So immediately I know it's going to be an open circle at 1 because there is no equal to. Then it says x, all my numbers x are smaller than 1. Well, to show all the numbers are smaller than 1, I'm going to draw my arrow going this way. This shows all the numbers smaller than 1. I'm going to go ahead and draw this one in purple. Well, it says here x is greater than 6. Well, there's no equal to, so it's going to be an open. And so then it says all the numbers are bigger than 6. Well, all the numbers that are bigger than 6 go this way. So in this case, our OR, they point in the opposite directions. ANDs generally tend to overlap. ORs can every now and then, but more than likely they're going to point outwards. And so this shows us all of the possible solutions. Any one of these numbers would work for either one of these equations. That's what it means to be a solution to an OR inequality. It has to work for one or the other. All these numbers in the middle are not solutions. So if I were to take 3, 3 is definitely not bigger than 6, and 3 is definitely not smaller than 1. That is not a solution. Now, the last thing we're going to do is write this in interval notation. So I'm going to work left to right. I'm going to start here. So first of all, I know this is a parenthesis because it's a less than, and I'm going to start at 1. And well, this arrow is going off on and on and on to negative infinity. Then we put a parenthesis around it. We can't put a bracket around an infinity. That's not a thing. We can never be at infinity. So it has to be a parenthesis. Well then, the other interval we have is we have this. Let's see, we've got 6. That's going to be my starting. So I'm going to have parenthesis, 6. And this one is going off towards infinity. Going off towards infinity. And so to finish this off, we need to write OR. From here, we're good to go. So we've solved an OR inequality. Just solve the parts, graph them, graph both lines on the same number line, and then we write it in interval notation.